srLib consists of three components within two main libraries. Lie group is the math library for advanced Lie group methods. srDyn is the primary library for multibody dynamics. Renderer is the 3D rendering library. Now, let's take a look at three different simulation demos of srLib. In our first example, we'll look at two mobile robots. One is for control with an engine, and one is passive. Here, we see the two mobile robots carrying a brown plate. The blue robot is passive and cannot be controlled directly by the designer. It must follow the direction of the red robot. When the robots move in straight lines, there are no problems. As you can see, sadly, once the brown plate is not touching both the red and blue robot at the same time, the blue robot can no longer move on its own. This proves srLib performs simulations very accurately when friction is used. This example also proves that srLib is very intelligent because it only allows mobile robots to move when their wheels are touching the ground. In this demo, there is a mobile bear robot. It has two sensors that can scan the environment around it. I guess you would expect that this bear robot has a pathfinding algorithm so that it can find its way out of the maze. Unfortunately, I'm sorry to tell you that it doesn't have one because I didn't program one into it. In fact, I'm just controlling it manually by keyboard so that I can guarantee it makes it through the maze successfully. Please note that as the mobile robot passes through the maze, the sensors record the data and transmit it to the controller. This data is simultaneously displayed by the green lines on the screen. This demo shows two humanoids who we will call Blue Man and Yellow Man. Yellow Man is totally passive, and he's simply positioned on the swing. Normally, robots are actuated by joint torque. However, srLib has the ability to actuate robots by joint torque or joint acceleration or a combination of the two. In this example, Blue Man is being actuated by only joint acceleration input. Generally, computer graphics animators are not familiar with dynamics, and therefore they cannot create physics-based animation easily. Fortunately for them, srLib is an effective and easy-to-use tool which solves this problem. Unfortunately, as you can see here, when srLib falls into the wrong hands, it can be very dangerous. So far, we've seen three unique simulation demos of srLib. Now, we're going to take a look at two different applications of how srLib is being used in the real world today. Normally, coding with C++ is required for conducting simulations. Unfortunately, that method is not as convenient as using graphic user interface. In order to solve that problem, RStation was developed. RStation is a standalone simulator based on srLib technology. RStation offers a highly intuitive and visual modeling environment. Users can quickly build various types of robot models and simulation environments with RStation's CAD-style interface. In addition, modifying the simulation and models requires very little effort. One of the powerful features of RStation is that it provides a flexible robot control interface. Through TCP/IP communication, RStation allows you to control robots using algorithms developed in MATLAB or any C or C++ software. This video shows a humanoid being controlled with MATLAB. Once again, you can see how easy it is to change the simulation environment using RStation. For the final segment of our presentation, I'd like to show you the very first case of srLib being used for hardware development and controller design. Earlier this year, a mobile manipulator called Krang was created by Professor Mike Stillman and his students from the Georgia Institute of Technology in the USA. Krang is a mobile manipulator that has two controllable arms as well as a base driven by the well-known Segway control. This is an example of an srLib simulation being used for the design of Krang's hardware. This concludes our video about srLib. We hope you feel it will be as beneficial to both industry and academia as we do, and we encourage you to visit our website to keep updated about future developments of srLib. Thank you.